Hi there, welcome to my channel. In this video, I'm going to discuss about the solution for reversing a part of the linked list. Let's look at the problem description. We are given a head of a singly linked list and two integers left and right. And basically we have to reverse the nodes present from the position left to the position right and return the reversed list. Let's take a look at the example 1. So this linked list has 5 nodes 1, 2, 3, 4, 5. And we are given the left position as 2 and the right position as 4. So starting from 2 to 4 we have to reverse. So it will become 1, 4, 3, 2, 5. And in the case of example 2, we are given a linked list with only one node and left position is 1 and right position is 1. So the expected output will be 5. The constraints for this problem are number of nodes in the linked list is n, where n is ranging from 1 to 500, and the nodes element value will be ranging from minus 500 to 500. The value of left and right will be greater than or equal to 1 and less than or equal to the number of elements in the linked list. Let's look at the approach to solve this problem. So we are given a linked list with 5 nodes and the left position value is 2 and the right position value is 4. Basically we have to reverse the nodes present in this range from position 2 to 4. Okay, so we can solve this by traversing the linked list once. As we traverse the linked list, we need to keep track of 4 pointers. One is the pointer to a node at position left and the node present before that node, the previous node of this node, and then pointer to a node present at position right and the node follows that right node. So these 4 pointers we have to set. So moment we reach the node at position right, we have to stop the traversal and then manipulate the links of the left previous node and the left node, the right node and the right next node. And as we traverse this section of the linked list, we keep reverse the links. Okay, so when we traverse the linked list, we locate the left position node and remember that in a pointer left PTR, and also remember the previous node in the left previous pointer. Once we locate the left, from then on until we reach the right position, we reverse the nodes. Once we reach the right, we remember the right node and then the next node after the right node. Okay, once we locate those 4 nodes, then we can update the links and then return the head of the linked list. So I have listed those steps here. First we initialize the pointers left PTR, right PTR, left previous and then right next pointer. Okay, and then initialize the node pointer to point to head and initialize the index to 1. Then we traverse right number of nodes. Basically the starting position is 1, so right number of nodes we have to traverse from the head. As we traverse, we check whether the index is greater than the left and less than or equal to right. In that case, we have to reverse the links, the nodes present in that range. So, and if that index is equal to right, then we store the current nodes to the right pointer and then the current node's next pointer will be assigned to right next pointer. And then we have to stop the traversal. And if the index is equal to left, then assign the current node to the left pointer and then assign the previous pointer to the left previous. Then in each iteration we have to update the link. So once we reach the right position node, we break out of the loop and then we manipulate the links. Basically assign the right PTR to the left previous node's next pointer and then assign the right next pointer to left PTR's next pointer. Then we get the partially reversed linked list. Let's look at the flowchart. Input for this procedure is the head of the linked list and then the left position and the right position. Okay. First we initialize the next, previous and left PTR, right next, left previous, right next pointers to null. And then initialize the index to 1 and initialize the node pointer with head. First we check whether the left is equal to right. If the left position and the right positions are same, that means both are pointing to the same node. So we can simply return the current head pointer. Okay. Then we enter the for loop. In this for loop, we traverse the linked list until we reach the right position. Okay. First we check whether the node is equal to null. If so, we break out of the loop. Otherwise, we save the current node's next pointer. Basically, we remember the next node's pointer. And then we check whether the index is greater than left and index is less than or equal to the right position. That means in this section we have to reverse the links. So that's what we are doing here. And also we check whether the index is equal to right. If so, we reach the right position. So we assign the current node to the right pointer. Address of the next node is assigned to the right next variable and we break out of the loop. Once we reach the right position, we should stop the traversal. Okay. Otherwise, we repeat that and each node's links will be reversed. So if the index is not within this range, then we check whether the index is equal to the left position. If so, we update the left pointer to point to the current node and the previous pointer is assigned to the left previous pointer. Okay. Basically we remember the left position node and its previous node. Then we just update the pointers to traverse the next node, increment the index and then we update the previous with the current node's pointer and update the current node with the next. So we move to the next node. Okay. So once we break out of the loop, we check whether the left previous is not equal to null. If it is not equal to null, then we update the next pointer of that previous node to point to the node pointed by the right PTR. Okay. Otherwise, if the left previous is null, that means the right pointer will be the new head of the linked list. Okay. So we assign the right PTR to head. And next we check whether the left PTR is not equal to null. If so, the left PTR's next pointer will point to the node pointed by the right next pointer. And finally, we return the head of the linked list. Let's move on to coding. First, I initialize the next, previous, and left pointer, right pointer, and then the left previous and right next pointers. Then I initialize the index to 1 and then I check whether the left position and the right position are same. In that case, we do not have to reverse anything. We can simply return the head of the linked list. Otherwise, I initialize the node pointer to point to the head of the linked list. Then I write the for loop. Each iteration, I remember the next pointer in the next variable. And then I check whether the index is greater than the left position and less than or equal to the right position. If so, I reverse the link of the current node. Basically that points to the previous node. the next pointer points to the previous node. Then I check whether the index is equal to the right position. If so, I assign the current node pointer to the right pointer variable and the current node's next pointer to the right next pointer variable. Then I break out of the loop, and if the index is not within that range, then I check whether the index is equal to the left position. If so, I assign the current node pointers to a left pointer variable and the previous node pointer to the left previous variable. Then I update the previous pointer and the node pointer variables for the next iteration and increment the index. Once we break out of the loop, we'll have to update the links of the node pointed by the left previous. So if the left previous is not equal to null, then I will make the left previous next pointer to point to the right PTR. If it is null, that means the left position is at the beginning of the linked list, so the right pointer will become the new head of the linked list. Then I check whether if the left PTR is not equal to null. If so, I assign the right next pointer to the left PTR's next pointer. Then finally I return the head of the linked list. Next I'm going to run the test cases. Okay, compilation. Let me fix it. Oh, there's a typo. Okay, let me rerun the test cases. All the tests passed. Next I'm going to submit this program. Cool, this program is accepted. Next I'm going to do the code walkthrough with sample input. Let's do the code walkthrough for this input. So this linked list has 5 nodes, 1, 2, 3, 4, 5. The left position is 2 and the right position is 4. First we initialize the next previous left pointer, right pointer, left previous, right next pointers. Okay, so the index is initialized with 1 and the node is initialized with the head that is pointing to the node 1. Okay, then we check whether the left position is equal to the right. If they are equal, then we have to simply return the head, but in this case they are not equal, so we proceed to initialize the node pointer with head. Okay, so the node is 1 and we are entering the for loop. Here we check whether the node is not equal to null. So in the iteration 0, the next pointer is set with the node dot next, so it points to 2, and then we check whether the index is greater than left position and less than or equal to the right position. In that case we have to reverse the link. Okay, so in this case it is less than the left position, so we are not entering here. In the else part we check whether that index is equal to the left position. This is also not true, so we simply update the previous pointer and advance the node pointer and increment the index. So when we leave, the index will become 2 and the node is up updated to point to the second node, then the previous pointer points to the current node, and then we haven't found the node at left position and the node at right position, so there all these 4 pointers are still null. In the iteration 1, current node points to the node 2 and we check whether the index is greater than left. In this case it is not, so we go to the else part. There we check whether the index is exactly equal to the left position. In this case it is true. Then we remember the current node pointer and its previous node pointer in these two variables. So the left pointer points to the left position node, the node at the left position, and the left previous points to the node present before the left position node. The left pointer is initialized with this node and the left previous is initialized with this node. Okay, then we advance the pointers and increment the index. So in the iteration 2 we check whether the index is greater than left. In this case it is true, and the index is less than or equal to right. So this the current index falls between the left and the right position, so we reverse that link. So that's why, so this link, this node next pointer points to this. Okay, I think this should be removed. Okay, so that is reversed, and then we update the previous and the node pointer and increment the index. So in the iteration 3 the index is 4. So when we check whether the index is greater than the left position and less than or equal to right positions, in this case it is true, so we reverse the link. So this link is removed and this is, so now the node 4's next pointer points to node 3. Okay, so once we see the node at the position 4, we remember that node's pointer in the right pointer variable, and the node which follows that current node is assigned to the right next pointer. Okay, so that's why we see the right pointer is initialized with the current node 4 and the right next is initialized with the node which follows that current node. Okay, so now left pointer is initialized and the right pointer is initialized, the left previous is also initialized and the right next is initialized. So once we reach the right position we break out of the loop, so we stop traversing the linked list. When we come out of the for loop, the linked list's link will be like this. Okay, so first we check whether the left previous is not equal to null. So in this case it is not equal to null. Then what we are doing, this node's next pointer will point to the right PTR. Okay, so after that link update the linked list will look like this. So the 1 points to 4, 4 points to 3, 3 points to 2. So in case if the left previous is null, that means the left position is at the head of the linked list. So when we reverse, the right position node will become a new head. So that's why if the left previous is null, then we make the right PTR as the head of the new linked list. Okay, so we are assigning the right PTR to head. Then next we check whether the left PTR is not equal to null. If the left PTR is not equal to null, then we assign the right next pointer to the left PTR dot next. Basically we are making the this left position node's next pointer point to the right next. Okay, so once that link update is done, the linked list will become, so the 2 points to 5. Then finally we return the head. So the head of the linked list is 1, 1, 4, 3, 2, 5. That is an expected output. Next I'm going to do the time and space complexity analysis for this solution. Time complexity for this algorithm is order of n. Let's take this case. So the linked list has 5 nodes. Okay. How many iterations this for loop performs? 4 iterations. So basically we have to traverse the linked list until the right position node is found. So 4 iterations this for loop. So if there are n nodes in the linked list and we want to find the right position is at n minus 2, then the time complexity is order of n minus 2. So if we remove the constant factor out, so that overall time complexity is order of n. Space complexity is order of 1 because we are not allocating any additional space. All we do is, regardless of the number of nodes in the linked list, only the 6 pointers are used to reverse the linked list. So the space complexity is order of 1. Thanks for watching this video. Have a great day.